Thank you. Yeah, I'm going to tell you about, I'm not sure if it should be pronounced CITUS or citus. I think CITUS like Linux, but it doesn't matter. Just type it, look it up. But, it's a solution that basically, in a nutshell, provides you or a new user with a complete scientific computing environment. So that can be very convenient, and it's relevant to making reproducible science. This is the logo for CITUS. So as you can see, we have a very pro-Debian bias. First disclaimer, this is not my project. This project was entirely developed by Emmanuel Quemener, who is in the room with us. He works at this HPC center, Centre Blaise Pascal in Lyon, France. So actually for any in-depth technical questions, I will refer you guys to him. And if you have VirtualBox installed on your personal laptops, you can go and see him, and he will give you a CITUS instantly, like in a few seconds, and easily, you can easily get a demo. I am myself from Montreal. I was a postdoc at McGill University, hence the affiliation here, up until a month ago. But I started a job as a business intelligence analyst just a month ago at WJAM. So the idea is to run a given OS. So you control what's in there, which versions for your software, etc., identically on different, potentially very, very many stations. So that can be a bunch of cluster nodes in the context of HPC. That can be a bunch of stations in the computer room if you're teaching, let's say, and you want to provide your students with one given environment, and you want to update the configuration or something. So very easily you can change what's in this environment and redeploy it. And we're coining this term COMOD for compute on my own device, because that's a solution for just using any laptop and just running a complete functional scientific computing environment on it using your very resources, because we want to be efficient and make the most of what's available. So really, it's not a terminal. The OS is stored remotely, but use is made of the local resources on a variety of equipment. The idea, I think you will agree with this because we're talking about reproducible science, is to consider a computing task a proper experiment, just like the traditional conception we have, concept we have for a biology experiment, where you control what's going on, you describe in details what you're doing, and you know how long it takes and what the outcome should be. Then same for a computing job that you submit. And the thing is, you're used to viewing HPC nodes as clones of each other, but they each run their own OS, and even if at first it's all identical, over time you will have trouble making sure that those different OSs are exactly the same. So over time it evolves, and so that's what I call identity over time. And between the different clusters, the different cluster nodes, you will have discrepancies as well, and that's what I call the issue of identity over ensemble using statistical physics language. So I'm going to illustrate what CITUS can do for you. So that serves as a diagnose for diagnosing limitations that you might encounter in an HPC context. So we're running this test about performance on 10 client-server pairs. So Emmanuel did this. I can show you the Python script very quickly for testing. So actually, there's a lot of bash in it, but It's still a Python script. And it's calling IOZone, which is carrying out the very standard input-output tests. Anyway, all this is online. You can look it up. We have data sets storing the results for read-write speeds, that kind of stuff. So, what is this guy? It doesn't matter too much, actually.
That's my,
It's okay if it goes away. I can go on.
IRC.
Thank you. So anyway, and also because I do statistical analysis, I'm going to use pandas, obviously. So we, in this CSV file, there are 200 rows. So basically 20 lines for 20 different runs over time for the 10 client-server pairs, and data in kilobytes per second for write, for rewrite, for read, etc. Yeah, so that's like, for instance, the index, which runs from 0 to 19, is like this bunch of tests carried out one after the other for the first client-server pair. And if I plot it for my 10 client-server pairs, I realize I have pretty huge discrepancies. So 8 of them are kind of like all close together, but 2 are like really far away, and also with discrepancies within for this given client-server pair. So I'm plotting here like a box plot, making use of pandas for not just write, but so the other standard input-output tests. And you see those variances, variabilities, fluctuations are really, really large. And because we are running a controlled, determined, given OS, which is the same on all those stations, we know variability cannot come from the software. So this led to a lot of investigations, and it turned out that you had to change the configuration to max performance in the BIOS. Is that it? Yeah, thank you. And then running again the same Python script that I showed you, the same standard input-output tests, now you would get a much nicer, closer, narrowed down variability over this data. This is the same scale as before. And I'm showing, this is like another run, again, in the same hardware configuration, max performance. And my box plot now shows much more satisfying variabilities. So CITUS proved to be a really useful tool to see what was going on with this little cluster node. It turns out that for another park of stations, it might be something different. Actually, it's been the case exploring around, so lack of reproducibility is reproducible. So in another case, like setting your stations to max performance might not be the solution for having a similar controlled behavior. It might be another setting. But there are many contexts, so like you want to rerun the same job exactly in the same situations. You want to teach your students something without the hassle of them installing something or downloading and then having to update, and they're not on the same wavelength. So CITUS is very powerful for this. There is some documentation over here. Oh, I think I opened the link before. Mostly in French. Some of it is translated, but not everything. Then if you want to make your own CITUS, there's like all the details for configuring your DHCP, TFTP, NFS. But please feel free to see Emmanuel, and he will give you a live demo, and hopefully you like it. What else? I think we just want to thank, so on my side, the sponsors who enabled my participation here, and for Emmanuel, this grant from the French agency ANR with CNRS. Otherwise, this project and like sharing it with you guys would not be possible. Thank you very much.
We have close to 10 minutes of questions. Yes, any questions for Marianne?
So you said, if I'm right, that this is something that runs the virtual machine?
Yeah.
How much, in terms of like computing on your own device, how much overhead does that, how much does that slow it down?
How much overhead? What? Excuse me. So the question was, this is running in a virtual machine. CITUS is running in a virtual machine. Excuse me, say that again, and?
How much overhead does that add? How much does it slow the computation?
With respect like to your resources in total?
But in terms of if you're running some computation on that, how much slower is it than running it?
Yeah, sure. Okay. Quantitatively, I don't know. So what is it? Yeah.
I can answer this question. In fact, it really depends on the implementation for virtualization. For example, if you use VirtualBox for a very huge combinational code, the hours will be at least 20%. If you use, for example, KVM on Linux, it will be from 5 to 10%. It really depends on the implementation. With SIDUS, you can put it in a VirtualBox, but for example, if you want, I can show you after the talk. You can put it directly, your laptop, under SIDUS. And in this way, you will use all the resources of your machine.
Anybody else?
So you said that the operating systems are stored remotely. Where are they stored, and what guarantee do we have that they'll be available?
So the question was about the OS being stored remotely. Where is it stored exactly? And in the future?
Will it still be there?
Yeah. Is it like persistence? So, yeah, I'll let you answer.
So the system is based on NFS root. So it's an NFS which is booted at the beginning. So you have to be on a local network in order to retrieve all the SIDUS instance. That's the first point. So secondly, how it is possible, because in this kind of thing, it's impossible to provide one NFS root read-write with read-write properties for each node which is connected. So there is two ways. There is a read-only NFS root which is provided, and another layer with a read-write which is a RAM disk, and it's not persistent. So it's really a problem, and we have explored several possibilities, and the possibilities we choose is to use a iSCSI persistent layer. So the node connect via NFS root for the read-only file system. It puts the iSCSI layer, which is read-write, and after, when you reboot your machines, the iSCSI persistent is activated. So you have a persistent node if you want. But in case of reproducibility, you want really to have exactly the same system. So it can be used, but in time to time, we have discovered that there is some entropy on your iSCSI systems, like this. Do I answer your question?
I think so. I need to read some more.
Any more?
Just a thought about, do a good job trying to make sure that all the OSs are all the OSs that are running, they're going to be the same exact thing, but, you still have, you're getting close to the iron as possible here, but you still have the issue of the virtual, the host machine running the virtual same version of the drivers, the same version of everything else. So
And the
that being
network
said,
as well.
have you come up with maybe schemes of automatically detecting that there may be these sort of inconsistencies that may still remain?
Okay, so the question was about we're throwing this effort into controlling as well as possible the identity in the OS, but there might still be discrepancies at lower levels with respect to how the stations really are, and I guess also depending on the network. But how do we systematically make sure that we have a control environment and everything is happening the
Yeah,
same
How
way?
do you try and automatically detect that these things come up again? You know, just kind of like how in any project where you detected a bug, okay, you fixed the bug, that's great, but you always add a test.
Yeah.
So how do we add?
How do you
go
automatically
about adding
detect
tests to detect
discrepancies? Do you have an answer for this?
This is more of an open question.
Yeah, it's more a general open question, but maybe you can say something about like this case where we're okay on other levels.
Yes, for example, in this case, we were sure that all the machines, all the cluster nodes were identical. And when we launched the tests, we see this lack of reproducibility. So it was the same machine, it was the same operating system. So we don't imagine that only a BIOS settings can produce so lack of reproducibility, because on the first case, there was a lack of reproducibility, but there was very, very low performances. And with only a change in the BIOS, we change this. And in another case, for example, you have said, I think, but I'm not sure, that at the beginning the system boot, but there are automatic discovery of hardware, and perhaps when you install a system from scratch, it has optimization process based on the hardware which is in the machine. And there is a possibility in CITUS, for example, to activate the microcode in processors. So you have to provide you launch CITUS machine with the NFS route which I've talked about, but in the init RD you provide all the microcode which is adapted to the machine which is booting. You can do this, so you can have optimization of the processors, and all the system is okay. This is another way to get all the performance of the machine, because if you take a very, very generic, it's not optimal. This is always a
trade-off.
choice between 1 and 0.
Yeah.
Question about reproducibility. So, if I understood correctly, you're able to make a snapshot of a cluster and then run it and see whether, run it maybe more than once and see whether it behaves the same way. Is there any way to channel this so it will behave the same way? Do you actually can take like a virtual machine, like snapshots of it several times and make sure that it runs the same way? Does your tool help with this?
So the question is, yeah, we're having this instance of citus. So the OS runs the same way over a cluster, and and like, can we have several runs to make sure it's still the same?
Can you make a snapshot of the cluster and then rerun
Oh, okay.
cluster with your tool?
Can we make a snapshot of the cluster and repeat it again?
Storage has
No.
to be
Forget
operating
about,
at projected.
forget about the limitations of storage. Can you conceptually do this?
Normally, yes. You can do. Normally, yes.
Conceptually, it should be possible.
I just wanted you to I'm just going to throw up a hypothetical use case, because it sounds like the sort of thing that some people might want to do, and that is in terms of reproducible science. One thing you want to do is regardless of performance, just take your underlying computation and then the paper that you're publishing and put it on some virtual machine somewhere. Now, in terms of a use case, does that CITUS, you can then download that virtual machine and run it locally.
Yeah.
Is that something
Yeah.
that you would actually say that that's what you've got is actually designed to do? Or is
Yeah.
that just a side effect?
Ex-
of the way that-
No, I think that, okay, so a question is about a hypothetical use case where, let's say, a scientist comes up with results that he ran on a given environment, in a given environment, and is CITUS able to like capture this environment, give it available for download, so that then the code can be rerun within this given environment. It's actually exactly the point. That's what CITUS is about, and yeah, absolutely.
Is there a web interface for that? Someone that's, only from a web browser you can log in into this machine and then get this reproducibility just from a web browser?
I can add this on roadmap, but I'm willing to make a demonstration.
Is there a web interface for using it? That was the question. Would OpenCF or something like this, or not even? Or- That's on the roadmap. That's the answer.
You have one more? There's any others? No? Okay, well, let's give a hand to Marianne.
Thank you very much.